Okay, linear programming. Examples. One more product mix question. So we're faced with a warehouse storage building, which must determine how many storage sheds of each size, large or small. So giving us some intuition as to how our decision variables are fleshing out. To build in its new 8,000 square foot facility, sounds like a constraint. To maximize rental income, objective function. Each large shed is 150 square feet in size, requires $1 per week in advertising, and rents for $50 per week. Each small shed is 50 square feet in size, requires $1 per week in advertising, and rents for $20 per week. Company has a weekly advertising budget of $100, sounds like a constraint, and estimates that it can rent no more than 40 large sheds in any given week. Again, sounds like another constraint. So our goal here is that we're going to want to maximize our revenues, maximize our rents in this particular case. So the journey starts out, as it always does, with what is our decision variable. Without knowing what that is, we have no idea what to do. We have no place to go. So we're thinking, okay, we have rents. What rents? Well, the sheds rent. What kind of sheds do we have? We have large sheds, we have small sheds, right? So when we think of what's driving rents, it's the number of sheds. Whether it's L for the number of large sheds, or S for the number of small sheds. Sheds drive rent. That's what we're deciding upon. The thing that drives whatever our objective function is. So our objective function is to maximize those rents, and then we have to, second consideration is, how do I calculate the rent? Well, a large shed gets $50 per week, and so I multiply by the number of large sheds to get the total amount of rent from my large shed business. Add to that the $20 per week I get for each small shed, and times that by the number of small sheds to get how much we make in our small shed business. And together, that's our objective function. We have constraints, of course, things that limit us. And one of the constraints that we have had is there's a maximum number of maximum area available for rental. Second thing is we have an advertising budget. So we have a maximum amount that we could dedicate to advertising. And then there's a demand restriction on the number of large sheds. So we have a max of the large sheds. Now we just kind of give the question a little bit of a scan here, just make sure we caught everything, right? Size, advertising, a large shed restriction, and it doesn't seem like we have anything else in there. Okay. Of course, we always have our two implicit potential constraints, which we'll consider at the very end. So maximum area. So we know that there's 8,000 square feet available. And further, we know that each shed takes up 150 square feet. So I have 150 square feet for one large shed, times by the number of large sheds, and that's how much all the large sheds take up. And each small shed is 50 square feet. So 50 times the number of small sheds. And that is capped at 8,000. We can consume less than 8,000, but we can't consume more. Advertising budget is $100, so I know it's going to be less than or equal to $100. And we spend $1 per week on the large sheds and $1 per week on the small sheds. So 1L plus 1S, that's under $100. The L themselves is the maximum number of 40 sheds, so less than or equal to 40 of those. Do they have to be non-zero? Yes. So L and S are both greater than 0, and nobody wants a partial shed. They want either a shed or not a shed, and so in this case they are going to be integers. So there's our whole action plan right there, from decision variable to objective function to constraints. Now that we have our action plan, we are all set to put this into Excel. Okay. So let's go with large sheds. We have our large sheds, one of our decision variables, and we have small sheds as our other decision variable. Again, each column represents one type of variable, or one variable. We have our rent per shed, and that's our coefficients for our objective function, and we get $50 for each large shed and $20 for each small shed. Our decision is to how many of each one of these types of sheds. So we have number. I'm going to highlight that in yellow because we don't know what it is just yet, but we're going to find out. And then lastly, we wrap it all up with how much rent do we actually receive from this. Nice little green. And we get to revisit our wonderful little Excel function, the sum product, right? Highlighting the coefficients as the first argument, and the number of L and number of S, or S and L, is the second argument, just like it is in our objective function. We've just put it in a format such that Excel can interpret it. And there's our objective function, and we're all set on that front. Last step, could go with the constraints here, and we have a maximum area. We have a maximum for advertising, and we have a maximum number of large sheds. So our coefficients for maximum area, 150 and 50 respectively for those large and small sheds. We have how much we use, and we're going to compare that to our limit. These are all maximums, so we're all going to be less than or equal to. Type in my less than, underline it, center it up so it looks pretty, and our maximum of 8,000. Maximum advertising, $1 a week for each type. Still, it's a maximum, so it's a less than or equal to, and we're spending $100 there. Maximum large sheds, so one in front of the L, nothing in front of the small sheds. It's a maximum, so it's going to be a less than or equal to as well, and less than or equal to 40. Not wanting to forget the sum products in the calculation, how much we actually use. We start off with sum product. And just like we've been doing before, we highlight the coefficients, highlight the number of large and small sheds. Make sure we push that F4 key because we want the number of large and small sheds. It doesn't change depending on which constraint we're looking at, so we want those absolute referenced, leaving the coefficients to be relatively referenced so that when we copy it down, Excel follows and looks at a new set of coefficients. Close that bracket, and then all we have to do is just copy that down, and we're all quickly all set to flow into Solver. Okay? So Solver, data, Solver. Yeah, I understand that. And so our objective function here is our rent. Right? We want to maximize it, so we make sure the maximize button is selected. Changing the variables. Okay, those are decision variables. Yeah, we've got some constraints, and we can add them all up here. They're all maximums, so I can select all three, keep the sign as less than or equal to, and then their respective limits. Don't forget the integers, so we're going to add integers here. So number of large and small sheds that highlighted in yellow values have to be integers, and then we're all set. Yep, so we've got everything all good here. We made unconstrained variables non-negative. Super simplex linear programming is all selected, so that all checks out. Let's click solve. No error flashing out on us. Great sign. Click OK. And now we see that we're going to produce 30 large sheds, 70 small sheds. That's going to produce for us a maximum profit or maximum rent of $2,900. We do see that the area is a binding constraint. So if we had more space, perhaps we would be able to make more large and small sheds available for rent and therefore increase our rental revenue. We also see that maximum advertising is a binding constraint. Right? We have $100 available. We've used all $100. The restriction on the maximum number of sheds, well, we could produce up to 40 max sheds. Right now, it makes sense for us to produce 30. So that particular constraint is non-binding. And that is everything with this particular question. Although you could also work this out graphically, and that would be probably excellent practice as well. Okay, thank you very much.